Hey, what's going on YouTube? Welcome back to Gotta Be Geek, and in today's video I wanted to go over using configuration in Azure Functions with a focus on Azure KeyVault. And you might be asking yourself, what do I need Azure KeyVault for? What is that? What am I going to use that for? And that's to store any of your secrets that you may need for whatever secrets you have. So you might be asking, well, what are secrets? What are you talking about? And secrets can be anything like a secret, like a password to a service account, password to a database, subscription key to some sort of service that you're interacting with. Any of those things can be considered secrets, or if you have certificates that you need to store or create, you can do all that in Azure KeyVault. And so we're going to go over using Azure KeyVault in your configuration in Azure Functions so that you can avoid ever committing or needing to commit or accidentally committing secrets into your source control. You might also be saying, well, I'm not really worried about that, Mike, because I have a private repository and nobody's ever going to look at that. Well, just because you have a private repository doesn't mean that one, someone isn't ever going to get into it or maybe crack your password, or you don't want to get into that kind of habit. There are much better solutions, Azure KeyVault being one of them, to avoid needing to ever do that. So we're going to go over some of that, and there's going to be some nuances and differences between Azure Functions that are written in C# versus Azure Functions that are written in Typescript or JavaScript, which you would see in like an Azure Static Web App, which if you haven't seen an Azure Static Web App video of mine, you can check that out up there and click on that, and I hope you like that video. And the final thing will be is that this is all going to be for pretty much anything that's .NET Core related, except for the TypeScript or JavaScript version of the Azure Functions, which will have its own kind of nuances. If you're dealing with just a front-end web application and you're not doing anything with the back end, there are some options that we can kind of go over that later in the video to kind of cover some of that. But just keep in mind that this is going to be kind of focused on anything that's a .NET Core related application. So the next thing I wanted to talk about is the subscribers for the channel. First off, thank you to the 138 of you that have already subscribed to this channel. I'm a little bit shocked that I've even already gotten that far. Obviously, it's nowhere near the millions. I mean, you guys can help me get there, but it's nowhere near the millions that our other channels have. But I'm definitely a little mind blown that I'm even at 138 so far. So it might seem not like a lot, but to me, it's still meaningful and impactful, and I appreciate all of you that have subscribed to the channel so far. I have noticed, though, that there are a lot of you that are watching these videos that are not actually subscribed to the channel. So what is up with that? Subscribe. You're watching the videos. If you want to see more, you gotta subscribe and hit that bell icon. Every time I'll drop a video, you'll get notified. The last part is that I still have the 1,000 subscriber goal. That's going to be the biggest one that I think I'm going to be focusing on for the near future. And I know you guys can get me there because I see that we've got over 1,000 unique viewers during the last 30 days. So there's over 1,000 of you watching of these, very literally 1,000 that are subscribing. I think all of you can help me get there to that 1,000 goal. And when I get there to the 1,000 subscriber goal, I will pick a lucky subscriber to get a giveaway item. And I haven't established what that item is going to be yet, but I will give away something for somebody when I get to the 1,000 goal. So look out for that. And if you want to be a part of that, you're going to have to be a subscriber. So subscribe to the channel and stick around for when that happens, and I will launch the giveaway event for that day. All right, without further ado, I'm gonna hop over here onto Visual Studio Code, and we're gonna get into using configuration and Azure Functions. Stick around. Is I've created an Azure function, and it's a simple kind of to-do list manager set of functions, and I've deployed it also to Azure so I can get everything set up. I'm not going to go too much into kind of how I did everything. I'm going to briefly go over kind of what everything does, but I'm not going to get too far into like the how to set it up and trying to explain everything in detail, because I want to try and keep this quick and focused on just the configuration aspect. So I'm going to bring this up, and then I'll go over the TypeScript one here in a little bit, but we're going to focus on the C# one first. So I have two endpoints, one for getting to-dos that I've created, one for adding to-dos, and then they both take in our to-do manager that I've created. And what you normally wouldn't see in an Azure function is this startup file. This is added in so I can have a unified place for dependency injection and boot up stuff. This is something that I've added in, but you won't normally see this if you just create a basic Azure function, but you can certainly add this in. You'll need to add a few different packages and extensions for config and things like that, which we're going to get into. And again, I'll have the links in my description for going to this repository so that you can kind of copy this if you want to and use it. Basically, this is just the kind of default things that we needed. some file stuff to figure out exactly where we're running or what context, whether we're running in Azure or running locally, and then setting up the config, and then building or setting up our services and building the config and all that good stuff. So then I've got the to-do manager here. And as you can see, our to-do manager is using our configuration here, and it's getting this Cosmos DB connection string. So the number one thing I already don't like here is I don't like having to use string literals for configs like this. I just think it makes it kind of annoying because then you have to set up probably like a constants file, especially if there's more than one thing using a Cosmos client. And so then you have to have this constant somewhere if you're using it more than once, and having all these config constants, and I think it just becomes a mess. And I'm not a huge fan of having to get configuration for connection strings differently than the rest of the config. It just feels kind of weird, and I like simplicity and consistency. So we're going to show the example of what that's like here in a second. But the challenge with this option, besides the things that I mentioned, is you have to have this connection string setting here. And when we're ready to actually do local development, let's say that I clone this repository, I made a new branch, and I want to make some changes. I want to work on this. I want to debug it locally. Well, I now have to go log into the portal. I have to get the connection string, and I have to copy and paste it here into this connection string setting so that I can run it locally. And then I have to remember not to commit that when I'm done with my work. I have to remember to go back, remove this, and then I can commit my work. And I've been pretty close. Luckily, I've never done it yet, but I've been pretty close a couple of times when I've gone through my commit changes and I'm like, okay, that file looks good. That's what I want to commit, whatever. And I usually catch it, but not everybody does. And I've seen people that don't. And then it's not a fun thing when you have to go mess with Git history and wipe all that junk to try and get rid of that, because and then you have to change the secret and the password for security reasons. It's not a fun process to go through. So we don't want to even have to worry about that. And that's what we're going to get into, is avoiding needing to even do this. So we're going to remove the need to even have to remember that. And we're going to remove having an inconsistent and different way to get that configuration. And one thing I'm going to show is that I have already put this in. Like I said, I already deployed it to Azure. And so you can see I've got the connection string here, and I've got the other config values like the container ID and the DB ID. And I will show you really fast that this actually works as is. I've gone ahead and deployed this. And so we're going to go ahead and hit this send button here to send a request. You can see I've already added a couple of to-dos. We'll go over here to the add to-do, and we'll do like my video. And then we're going to hit send. And then I get an ID for that particular one, and we can go back, and then we can, there we go. We got the third one. So we can see that works fine, and you can certainly do it that way, but we're going to go through the better way where we don't have to worry about that connection string. And then we're going to go through quickly deploying it so we can see that it works both ways, locally and deployed. And then you'll be able to see how that works. So in our to-do options, what I'm not using yet is this to-do DB key. And I've already removed the connection string. So then we're going to go to startup, and I'm going to add in the stuff that we need for Azure KeyVault here. So I've saved myself a little bit of time, and so I don't have to type it all up for you guys. I'm just going to cheat a little bit here in preparation for the video. I had already set most of this up. And so now what this is doing is this is building the config like we were before, because down here we're passing the config into the services. But the reason we're building it here and then building it, I'm going to get into why we're building it a second time, but we're building it here because we need to be able to actually get a value, and we can't get a value until we built it. So we build it so we can get our KeyVault URI, and then we set up our Azure Service Token Provider for MSI authentication. If you don't know what MSI authentication is, I'm not going to spend it. There's a whole lot I can talk about when it comes to authentication. So I have a link for maybe something about MSI in the description. If you're interested to do anything about authentication, again, that's like a series of videos I could probably do on authentication. And I did plan on maybe at some point doing some authentication ones. But if that's a high demand thing, I can certainly cover that a bit sooner. So maybe I'll put a link in the description for some stuff about MSI, but I'm not going to get too much into that. But basically, short and sweet is that this setup basically sets it up so that with MSI, either I have to have access to the KeyVault, or the application context that this is running in this case, the function in Azure, has to have access to the KeyVault. So the way that that kind of works is this identity here, and I've turned this on, and then this basically, and then I've gone into the KeyVault, and I've given that access to both myself and to the function app. So that's how it works. And you can see here I've only given the function app permission to read a secret. There's no need to give too many permissions to things or unnecessary permissions. I am obviously the owner on my own subscription, so that's why I have every permission that there possibly is here. But I don't want to give unnecessary access in the case that the function app was somehow compromised in some weird way. We don't want to give too much access that we don't need to. So the next piece here is the adding of the KeyVault to the configuration. And now that we've done that, we need to rebuild the config so that that's all kind of put in together. And then we just continue doing what we were doing before. The next step is to change this. So we can get rid of this ugly config piece. And we're going to do the URL for the DB. And then the key. And we'll remove the config because we don't need that anymore. And so now we have no more, ugly string literal that we don't need. And now we're going to have this key, DB key filled in by the Azure KeyVault stuff. And you might have seen it when I was on the secrets already, I think. But because the shorthand for, I'll go here as well so we can kind of see how that looks. So the shorthand for configuration, if you didn't know this, was these colons, right? Because we obviously can't do objects like we have in our config. We have to do the shorthand in the portal, which is with a colon. So you have the to-do section, and we have the two different values here. And then the way that you do sections in KeyVault configuration is with 2 dashes. So this was a big learning thing for me. It was really neat to figure this out. It wasn't super clear that I'll provide a link in the description for doing stuff like this in KeyVault. But reading the documentation to me wasn't very clear that this is how all that connected and how all that worked. It just talked about doing these dashes, but didn't explain that this is how that would work for filling it into options when you add in the KeyVault config. So that's what we're trying to showcase here. So now we have this key for the Cosmos DB, and now everything can kind of work. So we should be able to run this locally, and if everything wants to be nice and be on my side, it'll work. All right, so I did have to cut this over a little bit. So you saw me starting this up. I did run into an issue, so I'm going to go ahead and share what that issue kind of was and how I resolved it. But I didn't want to spend a lot of time while I was trying to figure out what I missed. I had forgotten that I hadn't actually run this aspect of having the KeyVault set up on here. I've done this plenty of times for work and other things before, but I hadn't actually done this on my computer and stuff before. So one thing I hadn't done was for the MSI stuff to work and the authentication, you need the AZ CLI installed. I'll have a link for that in the description below, but basically it couldn't run the authentication method to get me signed in to access the KeyVault, so it had failed when it tried to boot up. So I resolved that. We're in business now, and so now you can see the functions are here and ready to go. And so if I go to Postman and I go to the endpoint here, I've changed this to the localhost endpoint, and we can see I can hit that. It's okay, and everything works there. So now you can see in local config, we have gotten rid of all the stuff that we ideally wouldn't want. We don't have to worry about the key anymore, and now we can deploy this, and it can work just the same locally as it does deployed. And so I'm going to quickly deploy this, and then we'll see the settings change in Azure, or I'll change the settings in Azure. We'll see what that looks like, and then I'll run it one more time there so we can kind of see what that looks like. Okay, so like I said I was going to do, I've deployed the Azure function to the portal, or to the Azure portal, so that we can validate that it indeed does work the way that it now did locally using Azure KeyVault. And so a couple of things I've done here in my settings is I've added the to-do DB URL property, which was in my local config, and I wasn't using that originally in the deployed one because the URL was included in that connection string that we had. So now we've separated out the URL and the key to be separate, and the key is coming from KeyVault. And as you can see here, I've also removed the connection string that we had here in the portal so that we can be sure that everything is working how I would want it to and that's using the KeyVault settings. So the next thing I've gone ahead and done is changed this URL to be the deployed one instead of the local one that we were using earlier. And then this is the same data we had from before, but we'll go ahead and hit this endpoint again. Now that we've hit the local or the deployed one, we're getting the same data back, and it's using Azure KeyVault. And now we're using the same config across local and deployed, and we don't have to worry about committing any secrets to source control. So I think that this is a big win-win in all departments. The next aspect that we're going to go over, which I'm going to switch over to the kind of TypeScript version of this, and we're going to go over some of the differences and nuances for a TypeScript or JavaScript Azure function, because some of that setup and kind of boot up aspect and things like that are going to be a bit different. So we'll swap back over and we'll take a look at that. All right, so here we go. We're going to do the TypeScript functions that I had mentioned before. And so I've gone ahead and, like I said, made a TypeScript kind of variant or compatible version of the C# Azure function that I made before. And similar to that one, there's the kind of add to-dos function and a get to-dos function. Didn't go in depth any further than that. And I've done a few things to accommodate some of the downfalls that we have from, or things that we don't get because we're in TypeScript versus .NET Core or C#. So with .NET Core, we have the dependency injection that comes with that. And so that allowed us to do the startup file and create our dependency injection and the configuration and the extensions that .NET Core provides to kind of pull in from your config and all of that. So a lot of that stuff that gets simplified away is not here. And there are some suggestions and thoughts that I have for resolving some of that. But we're going to go through some of this, and you can kind of see the things that I'm referring to. So the first thing we'll do is we'll go to our get to-dos function. So relatively simple here, nothing too crazy. I've created a function that allows me, and the reason I've done this, actually I'll kind of, before I further explain it, is that there's a website, which I'll have a link for in the description below, but it's a kind of do's and don'ts for Azure Functions or serverless APIs. And one of the things that they mention is making sure that you're not constantly recreating connections. So if you're using a Cosmos client, a secret client for KeyVault, or an HTTP client, that you don't want to be recreating those all the time. This goes for .NET Core as well. You don't want to just keep creating an HTTP client or a Cosmos client. You want to take advantage of dependency injection and have singleton or static references to things, because when you scale these things out, when you have to recreate that connection every time, you start running into errors. And they have like some graph and some examples on that site. So I think it's really helpful. Definitely check it out in the description below. But basically, I tried to follow some of that pattern. Rather than having to recreate the secret client and recreate the Cosmos client inside each trigger, I made a common folder here with our to-do manager, similar to before, where once we've created one to-do manager, I return that same one from that point on, so that we're not recreating all of those clients and instances that we would need to do on the very first one. So what that means is that basically on the very first time, if you're running this locally or in the Azure, deployed in Azure, the first time it's going to take a couple seconds for it to respond with whatever it is you're doing, whether it's adding a to-do or getting the current to-dos from Cosmos. Then after that, subsequent calls take anywhere between 50 milliseconds and a couple hundred milliseconds. So a lot faster on subsequent runs, because now we have those static references things. We're not recreating those connections, so we're following those best practices. So this is pretty obvious, I think, at this point. I have an asynchronous function because the reason, and this isn't what I would probably consider the best pattern, but this was simple enough for this example. So don't take this as the holy grail of examples, I guess, on how to do this, but it does work. So it's an asynchronous function, which I'll get into, that creates the to-do manager. And the reason it's asynchronous is because when we create it, we need to get our secret or a key from Cosmos, and that key, or doing that, is an asynchronous operation. So thus, if we're in the first case where we actually are creating the secret client, we're getting the secret, we're getting our client connection, that is asynchronous. Subsequent calls, that isn't asynchronous, because it's wrapped in an asynchronous promise, but it's just returning the same to-do manager, so it's really fast. So not probably my ideal approach, which I'll go over some thoughts and suggestions maybe in a future way to do this. But then we go through the to-do manager and we get the to-dos, and then we set that as our body response, and there we go. And we're returning the to-dos just the same way that we would have been before. And so then I'll go quickly over the to-do manager. Again, this is really similar to the to-dos manager that we had in C#. We're just getting the database, the container for adding one, and we're creating a GUID, and then we add the item, return the ID, and then here we're just doing a select all essentially to get all the items and then returning those. So there's nothing too special here. We're passing in the Cosmos client in the constructor, and then we're getting the config. And so this brings us to the next one is configuration is something that the .NET Core dependency injection gives you with its extensions to add Azure KeyVault. So we can't do the the iOptions stuff that we with configuration that we would do in .NET Core. And so in here, all of the configuration is passed in through the process environment variables. And the one downside to that I would say I'm not a huge fan of is also because in this version of getting config, the way that it populates those is that you have to do them all in the values section. You can't have the section configurations like you could in the C# .NET Core version, which is kind of a bummer for me, but maybe not a huge deal breaker. I can't talk today. But just as a heads up, I did try it. Section configuration does not work. If you've gotten this working, feel free to share it in the comments section below, but I could not see it working and I didn't understand why or what I might have been missing. Maybe it's a setting, I don't know, but it didn't work for me. So going back into the to-do manager, so that's how we get these config values out is the process env, and then they get attached into there. Then going into our index file here, this is where all of that setup and stuff happens. So we have these references to the Cosmos client to-do manager so that once they're assigned, then we can just return those original ones rather than having to recreate them. So in this case, if to-do manager is null, obviously we need to set up the Cosmos client, and then we pass in our static reference of the Cosmos client. We create a new to-do manager, and then if we have a to-do manager, then we just return that to-do manager, and then we export that function so that once it's called, it will just always return those same things rather than just doing a new one every single time. And so I forgot to do that. I think that pretty much covers it. And then the setup Cosmos client, this is the one that's going and getting the secret and then applying that key so that we can use it in our Cosmos client configuration. And that's pretty much it. There's not much else to that. Now, the suggestions I would have here is, and here's the add to do, also really similar, it just creates it. And because we've already created it once, for whichever one gets called first, we'll call that function, and then it will get created so that both to do or both functions end up accessing the same reference, I guess you could say. So both of them end up really fast with that. And this one, we just take the body, which is a JSON of an to-do. And so that's why we just use this as here, and then we pass that in, and then we return the to-do ID once it's created it. So there's the optimization I would say for this is there's a library, which I'll have a link for in the description below. It's called Inversify.js. And I've used it in one other project before. It's dependency injection for TypeScript, or I guess you'd say JavaScript as well, but I think its focus is around TypeScript. Don't quote me on that, but I've only ever used it in a TypeScript project. And I think that this would be a good candidate for that. I think it'd be interesting to see if there was a way to create basically kind of your own configuration bundled into the dependency injection and do a similar behavior from what .NET Core's dependency injection does, and maybe make a configuration provider that reads the sectioned config and then turns that into like an options class of values similar to the way .NET Core does. So I think that might be like a fun project for me, something I may try, and then if it goes well, I may make a video about it and explaining how I did it, and share that. But I think this would be a good candidate for that, because personally, while it does work for this very simple example, just to kind of showcase some of the differences between if you went the .NET Core and or the TypeScript route for an Azure function, I think that I'm not the hugest fan of this, because the minute you start maybe having a serverless API that does a lot more than just manage to-dos, then you end up with maybe a lot of these that you have to do for different managers, and that's where the dependency injection stuff comes in. But that could also mean maybe you're getting beyond the point of a simple serverless API, is if you have too much going on. I don't know. I'm not. This worked, but I'm not a huge fan of it. So if you have other suggestions on this, if there's a way that you handled this, I would love to know about it in the comments section below, because I think that doing it this way is, like I said, doable, but I think there's probably other better solutions. Maybe there's some that don't involve using a dependency injection framework like Inversify.js. So definitely share your thoughts in the comment section below. If this helped you, also let me know about it in the comment section below. And this is going to be the same. I'm not going to deploy this one to Azure, but it's because it's the same in this case. We're creating the same concept where the configuration will end up being the same. We would just have to add all of these config values. We would have to add these into the portal, similar to the way we did with the C# one that we deployed. So all this means is that, similar to the C# one, we're going to have the same config experience whether deployed or running locally, and that was the aim of this whole concept. But I think that given the way that you have to do this, unless you really don't want to learn C# and you're all about TypeScript and front-end applications, or you just want to stick with TypeScript or JavaScript, unless that's the case, I would say probably go with a C# or .NET Core Azure Functions versus the TypeScript ones. So the only time that I've done the TypeScript ones other than this would be when I created my Azure Static Web App. So I have a couple videos on that, which I can have link for on the top for you to click on. But but that's the only case I can think of where that's the function that it creates. And what I also haven't tried is seeing if you create an Azure Static Web App, if you can instead do a C# Azure function instead of the TypeScript one that their template creates for you. So I think that would be something also interesting to try. But let me know your thoughts on this below. I think we've covered all the bases here, and so I think this should be pretty helpful. And I will have a a link for the repository for this in the description below, as I usually try and do for these examples. There will be as you can see here, I'm in this TypeScript folder. Once I create the repository for this, there'll be a TypeScript folder and a C# folder within the same library, so that you can see the C# functions and the TypeScript one for yourself. Well, hopefully this video helped you better understand how to use Azure KeyVault with your configuration in Azure Functions, or pretty much any .NET Core application as we've seen. I love doing these kind of videos because I like doing videos that help people find answers and solutions to problems that may have not had the clearest answers to begin with. So if this video helped you, then definitely smash that like button so that I know, and tell me what was your favorite part of the video in the comment section. And if you think there's a better way to do the configuration stuff that I went through in this video, then definitely also share that in the comment section below. You not only help me learn, but you help everybody watching these videos learn, and my way definitely isn't always the right way. So if you think you have a better way, don't be shy, share it in the comment section. I think everyone else would obviously appreciate other ideas and suggestions other than just mine. So that's gonna be it for me, but as always, it's not it for you. If you haven't hit that like button already, go down there and click that like button. And if you haven't subscribed and you're part of that big old group of like 1,000 people that are watching these videos and haven't subscribed yet, hit that subscribe button, because we have that 1,000 subscriber giveaway that I plan on doing now. So if you wanna help me get there and get that goal, and you wanna be a potential winner for the giveaway, then you're gonna need to hit that subscribe button, hit the bell, and then I will see you guys in the next one.